On this video, I want to talk about making sinusoids. These are the shapes of the graphs we get when we graph sine and cosine. And by the way, this little symbol here it's pronounced theta, T-H-E-T-A. It's often a symbol we use for rotations. But let me do that in just a bit here. I want to first of all talk about kind of one way to make sinusoids is just to do it numerically, a table of values. So I've opened up a Desmos window here, and I'm going to insert a table and just have Desmos plot some points. So for example, 0, and then over here I'm going to have this be equal to sine of x1, and so 0 degrees has a sine ratio of 0. And then if I go to the next one, I'll go say 30 degrees. That has a sine ratio of 0.5. And I could go ahead and keep going on here. See if this will, and I can just kind of keep generating points, plugging points into my calculator or Desmos, and we can start to make what's called the sine wave or the sinusoid. And you can kind of see that for the sine function, and the graph climbs, it reaches a peak at 1, and then comes back down here at 180, we're back to 0, and then we start going through the negative values of sine. And again, this we refer to as a sinusoid. It has a cycle or period of 360 degrees. It's how long it takes to repeat itself. It has an amplitude of 1 unit. It gets up to be 1 unit above and 1 unit below this line we happen to call the sinusoidal axis. So that would be the sine graph. We can also make a graph for cosine using the same idea of, let's start with a table of values, and this time I'll have x2, and I'll go cosine of x2, and now I can start plugging in values. For 0, the cosine of 0 degrees is 0. Go down to the next one, let's say 30 degrees. The cosine is 866. And if I were to keep going through that pattern, okay, I start generating the cosine wave. It too is a sinusoid, but notice how it's in a little different location than the sine graph. Here, let me shut off the sine graph. So that's what the cosine graph looks like. It also has a period of 360 and an amplitude of 1, but it's in a different location than sine. Here's the sine graph just for comparison. We say that they're out of phase with one another. So that's kind of a numerical way of looking at sinusoids and sines and cosine graphs. I'd now like to look at it a little different way with you. Let me get this paper out of here. We're going to talk about the idea of of transferring or projecting lengths. And let me just kind of show it to you. It's probably easier to show it to you than to try to explain it in words. So what I'm going to do is, here I have a unit circle, a circle of radius 1 unit, and I've put little marks here, be 30 degrees, 30 degrees, 60 degrees, 90, 120, 150, 180, and that's representing how much rotation I would take to go around the circle. So one way to figure out sine, okay, is to basically track the height. And so I'm going to do here is I'm going to a little rotation of, so there's my rotation of 30 degrees, and so here's the height, okay, of the point at that case. What I'm going to do is I'm going to transfer that height over to my graph. I'll try to keep it at the same height, but I'm going to go to 30 degrees and I'm going to put a little spot right there. So at 30 degrees, that would be the sine value, which happens to be 0.5. By the way, at 0 degrees, I have no height, so that would be right here. Then I'll go to 60 degrees. So let me turn my rotation to 60 degrees. Okay, so now I've got a rotation of 60 degrees of rotation, and I'm going to take this height and I'm going to transfer that height over to 60 degrees on my graph. And so at 60 degrees, the height is right about there. So as you continue to go around just transferring the heights, that might be a little too far up. I think I overshot a little bit, right about there. So when I rotate to 90 degrees, well, here's the height of 1 unit. So at 90 degrees, I have a height of 1 unit. At 120, right over here, I'm now back to this height. And so if I take this height, transfer it over to 120, it's the same height as it was when it was at 60 degrees. Going to 150, and then transferring that height across to 150, right here at a half. At 180, I have a height of 0. So at 180, I have a height of 0. And continuing on at 210, well, now I've got negative height, or height below the axis. So I'm going to be going down at 210, right about there. At 240, right here, the height, if I transfer that height over, right about there. 270, we're right here. And by the way, if you kind of see where I'm going, feel free to fast forward the video. 300, which is right here, I'll go across to 300. And almost there. So then 330, the height at 330 would be right about there. And at 360, I'm back to where I started. Now I could keep going on and say, well, what happens at 390 degrees? Well, at 390, I'm back to this height. So at 390, I'm right here. So this graph will continue to climb up. And you could also do negative angles. So if I go negative 30 degrees, well, then the height for negative 30 degrees is right here. Negative 60 degrees, the height for negative 60 is right about here. And then we'll do one more. Negative 90 would be right about here. So this, and then we'll go ahead and connect this with a nice smooth curve. This is the sinusoid for the sine function. Oops. And right when you get to here, you get a little bit of inflection. The curvature kind of changed a little bit. So again, this is y equals sine theta. Notice that it has a period or cycle equal to 360 degrees. It takes 360 degrees for the cycle to start repeating itself. It also has this displacement here of 1 unit. We call that the amplitude. So amplitude is equal to 1 unit. And notice that it kind of starts right at the origin at 0, 0, and then it starts to go through its pattern. So that's the sine function. Now let's look at the cosine function. Well, in order to get cosine, you have to again track points, but now you're going to track the horizontal displacement rather than the vertical displacement. So if I go to 0 degrees, okay, horizontally I'm 1 to the right of center. So I'm going to take that 1 and I'm going to transfer it right down to here. Okay, I have kind of a sideways graph for now. You'll see where I'm going with this in a moment. At 30 degrees of rotation, okay, I have this much horizontal displacement. So I need to transfer that displacement down to 30 degrees. So right about there. If I continue to 60 degrees, well, I have this much horizontal displacement at 60. And so 60, if I were to drop that down, it'd be right about there. And at 90 degrees, well, I have no horizontal displacement. So at 90 degrees, I have 0. And continuing on, 120, my horizontal displacement. If I transfer that down, right about here. At 150, let's transfer that one down, right about there. And at 180, well, I'm all the way over to the left 1 unit, so let's take that down to right there. So I'm starting to kind of create what we call the cosine function, which is keeping track of the horizontal displacement. So 210, I now have this much horizontal displacement, which I'll transfer down to 210. And again, feel free to fast forward the video if you got the idea already. 240, let's transfer that. At 270, I have no displacement, so I'm back to 0. Let's see, continuing on, we're at 300 degrees. 300 degrees, we're to the right, so plot that right about there. I'm running out of room on here, but I think you get the idea. 330 would be right here, so then let's transfer that down to the 330 mark. I'll move this paper in just a second. And then finally at 360, which is right here, we're going to transfer that down to 360. And then we'll kind of connect that with a nice smooth curve, a little inflection right there, change the curvature. And a little turn right here. And we get to that point, another little bit of inflection right in there. And this is the cosine function. So I'll go ahead and rotate this sideways now. And that's the cosine function, y equals cosine theta. This also has a period or cycle of 360 degrees before it starts to repeat itself. It has an amplitude of 1 unit. It's just in a different location. In fact, if you did some negative angles, you could continue this pattern. Make that a little more complete for you. Okay. And so this, again, the name of the shape is a sinusoid. Okay, the function this is the cosine function, but its shape is called a sinusoid. And up here we have the sine function, which is also a sinusoid, but it's just in a different location. So that's looking at sine and cosine from sort of a displacement perspective. When we're keeping track of height, okay, we're really keeping track of sine ratios. And when we're keeping track of sort of horizontal displacement, how far right and left we are of center, that's what the cosine function is based upon. So let's see if I can, I may have already covered that up. Let's see if it matches the Desmos graphs. And you'll see that these do hopefully correspond with the ones I've gotten by hand. So thanks for watching.